Okay. So I'll just go over basically all the theory of the semester real quick, but just briefly to just remind you of the main points, and then you can ask questions if you have any. Do you see my screen?
Yes.
Perfect. All right, so the beginning is basically the same as we had for the midterms, the presentation. So for the first chapter about the averages and the sigma. So the averages is basically what we use in many other classes as well. So you should know that by now. Then we have for example, the arithmetic average, where you just add different values and divide them by the amount of values you added. And then we have the weighted average. That's the same that we're using for accounting for tomorrow for some of the cost of goods sold. The weighted average, so you just take how many people, for example, measure 176 centimeters, and then people with other heights and divide it by the total of people. Then for the sigma, that basically just means to sum things up. So the sigma sign is the one that you can see on the screen. And it's basically summing up an operation, a term, like for example, 3 times a certain amount, and it will increase by a certain amount each time. And that's all indicated in the sigma sign. So it starts at 1, I equals 1, and goes until to 5. Then fractions. Here you have the basic rules of the fractions. You have it from the teacher as well on all the cheat sheets. So definitely just look at it for the exam. It's best if you've memorized some of it. That way it's quicker at the exam. I won't go through all of it. You can look at it by yourself. And then for the percentages, that should be clear by now as well. So for example, 90% means that you take 0.9, the amount of whatever you want to calculate. And 0.5 means half of it, for example. Then growth rate. That's something we used a lot in F&B for the cost control midterm. So you might remember it from there. It's the same thing. You take the final value, you subtract the initial value and divide it by the initial value. So for example, if you made $900 this year and last year it was 1,000, you do 900 minus 1,000 over 1,000, which is minus 100 over 1,000, which gives you minus 0.1, which is minus 10%. And you can also do the same thing. It's to check what your final value would be if you have the growth rate. Then markup and return is very simple. You just have to remember which one is which one. So markup is your profit expressed using the cost price, and the return, the same thing, but using the selling price. So the principle is the same for the two things. It's just you divide it by either the cost or the selling price. So markup is always connected to cost and return to the price you're selling it for, like you can see in the example. Then growth rate, if your final growth rate is smaller than the one you originally had, it means it's lower than 0. That means that it's decreasing. So it must be minus a certain percentage. And the same for the opposite. So if this year you made more money than last year, it should be bigger than 0, so a positive percentage. Then exponents and logarithms. So that an exponent is basically when you do a number to the power of a certain number, which is also important for the derivatives. So if you have a derivative, there's many times, for example, e if you have e to x or e to 2x, remember that the power can be like a second function. So you always have to be careful how you take the derivative of it. I'll come back to that later. And remember that this part, because it might get a bit confusing at the exam, but when it's in the exponent denominator, that means that it's just the root of that number. Here you have all the rules, which I won't go over right now. If you have any questions, you can ask them at the end. But it's easier when you remember a big part of them, because it's easier to recognize when you're doing the calculations. But always keep them next to you anyways, just to make sure that you don't make mistakes using them, because it happens to me sometimes, and then it messes up everything, even though you basically understand what you should be doing. Then tips for the calculation of the logarithm. So with the calculators we are allowed to use, you cannot put in the base that you are using. So you have to calculate it the way you see it right here. Yeah, because we unfortunately are not allowed to use anything that can do that. You just have to remember this formula and put it into the calculator this way. And if you have a logarithm, just to like kind of try to understand how it works, what I always try to do is I say, okay, if I have here b, I have to raise it to what power in order to get this. So if I have b, I have to raise it to which power in order to get x. So that's the way I always think about it, and it makes it easier for me to understand the concept of it. Then some additional useful rules, which you can look at later. You will get the PowerPoint. Remember that the logarithm of 0 doesn't exist, because if you do any number to the exponent of 0, you get 1. Okay, so you will never get 0. Remember that. And also something important, if you have e raised to ln, ln basically means logarithm with the base of e, and they cancel each other out. That can be very useful at the exams to solve certain things. And same thing for 10, if you have the logarithm of 10, basically any logarithm, if you have the base here, like 10, and logarithm to the same base, they cancel each other out, and you're left with 6, like here. And this is basically what I just explained, that logarithm to e is equal to ln. And yeah, you can look at this later if you need it to remind yourself of it. There's also the rules that for the logarithms, which are useful for solving equations. Then the interest, that's basically also just remembering the formula and plugging it in at the right place. Always remember also to have the right, if you have it in months or if you have it in years, to have the right, how to say, to put it in years and not in months, otherwise it messes up your calculations. Just remember what t exactly is. And yeah. Then for equations. So here you have the example of a linear function. A linear function is always works the same way. You have your slope, which is m, times your, for example, x, and then plus the y-intercept, the h. So the h is always the point where your line crosses the y-intercept. So here it would be -1. Then here you have the cross multiplication, which is useful useful when you want to solve things, and for proportions. Then for the quadratic equation, that also has a fixed way how it's built, as you can see up here. And you can also write it this way, as you can see down here, which makes it sometimes easier to find the solution you're looking for, but not always. And you can, when you have a quadratic equation equal to 0, you know it's 0, then you plug it in to this formula, which you definitely have to know and will have to use a lot, and to get your x values for it. Then the minimum and the maximum. So if you have the first derivative equal to 0, or if you do minus b over 2a, it's the same thing, okay? First derivative equal to 0 or minus b over 2a means that at that point you have a vertex. And that means that at that point the function, the slope of the function is 0. As you can see here, so it's a minimum or a maximum. I'll come back to that later. Then important to remember, these all are also just some rules that you best know by heart in order to be faster at the exam and to not mess up anything. Then to systems of equations, first to the rules. So to find a certain amount of unknowns, you need to have the same amount of equations. So if you have 3 unknowns, for example, in the Lagrange method, it's lambda and, for example, x and y, you need 3 equations to find all those values. And those equations need to be distinct. So as you can see down here as an example, that is not distinct. So as soon as you can like simplify it in order, and they look the same in the end, then they're not distinct equations. It's just the same thing and written in a different way. Then to the types of linear equations, they can either have one solution, infinitely many solutions, or no solutions when you have 2 and want to find the intersection. So they have, I start with the infinitely many solutions because that's the same as not the non-distinct. So that they're non-distinct basically means that it's the same line. If you have a graph, those 2 lines, those 2 functions will be on top of each other because it's the same function. And if they have no solution, as you can see in the on the bottom, means that they have the same slope, just a different y-intercept. So it would be a line with have look the same, but just one would be higher than the other one. And it only has one solution when they just cross in only one point. So the y-intercept is different and the slope is different. Then there's 3 methods to finding your intersections. So you can either graph them and just find the intersection this way, which is most of the times not very useful because it's imprecise. It's only useful when you use it for solving inequalities to find your range. But when you're just looking for one point, I wouldn't use this one. I would, for example, use the addition method, which works when you have linear equations many times, which means that you subtract the equations from each other. So here, as you can see in the example, you always need to have in the first and the second equation one variable that has the same, is multiplied by the same number in order to get rid of them. Because if you don't get rid of any variables, there's no point in using this method. You have to get rid of one of the variables after you subtracted or added them. So in this case, you get rid of the a, and then you can solve for your c and plug it back into the original equation, and you get your a. Then this would be the substitution method. And this is the method that works all the time, which is also used at the end, at the optimization. It's the same principle. So you basically solve for one variable, which one ever you want, and you plug in what you solved for into that variable. So here it's c, and then you plug in for c your 11 minus a that you solved for before. And you can solve for your a and then plug it back into c. That's always the same principle at the end. And this one always works. So when in doubt, do this one, it will definitely work. Then to the inequalities. So for inequalities, first of all, you should always first look at the functions as if there was not an inequality sign, but an equal, okay? So for example, here for c, it would be c equals 4. And then check, okay, if I have c equals 4, where would it be, that function? You check where it would be, which is the red one right here. And then you check if it's, which type of sign is there. So if it's if it's only bigger than, then it's a dashed line. And a dashed line means that the 4 is not included. So only things that are bigger than 4, but not equal 4. For f, it's not dashed line, it's a normal line because the 2 is included in the solution set. And for the last one, here it's always the best to solve for, in this case for f, in order to, and then graph it, and then you can check which part of the solution set is included. And then you just mark all the parts that are included in the solution set and where everything meets, like here in the black part, that would be your solution set. Just always be careful about the bigger than or equal signs to not miss a solution or not count something that you shouldn't. And then something to remember, to only round final values, because that's something that can mess up your calculations a lot. So don't try to round them before just because it's easier. Do it at the end. So this was all what was at the midterms, and now we get to the part that's new since the midterms. So the derivative. So the derivative is basically the slope of a function. When the derivative is bigger than 0, it goes basically kind of, you can imagine it's going uphill, and when it's smaller than 0, it's going downhill. That's how I always think of it. In order to find the slope in a linear function, you can use the change in y and change in x. But only use that for linear functions, because non-linear functions have slopes that are different at each point. So you cannot use that. You have to use the derivatives that you have a table for in your cheat sheet from the teachers, how to take the derivative of different terms. And this would be the official definition of a derivative, how you can do it, but that's just for you to know where it's coming from. And you should use the table from the teacher. Then the first derivative, like I said, is the slope of a function. Here on the left side, you can see the way a derivative can be written. So there's 2 ways, so don't be confused if you're only used to one of them. Get used to the other one as well in case it's on the exam. You can see that here in the graph, in the first part, it shows that if the derivative is smaller than 0, it's going downhill. That's how, downhill. That's how I imagine. That's why I'm saying it like that. And if it's increasing, it's positive. So the first derivative is bigger than 0. It's like going uphill. And the same thing at the end of the graph. Then second derivative. So the second derivative is kind of difficult to imagine what it is, but it basically just describes how the slope evolves. You don't have to like directly exactly know how to imagine it. The most important thing is that you know how to take the second derivative. So it's the derivative of the first derivative, and that you know what you use it for, which is for basically one thing, and that's to determine if it's a minimum or a maximum. So if your first derivative is equal to 0, that means that the slope is 0. So that would be, for example, right here, because you can do a vertex here. Then you take the second order derivative, because normally you don't have a graph, so you don't know if it's a minimum or a maximum. With the second order derivative, you will see that if it's bigger than 0, it is convex, so it's a minimum. And if it's smaller than 0, it's concave. So how I imagine it, and the teacher said it as well, convex, like for me it sounds like a happy word, convex, so a happy smiley, and concave, like a sad smiley. Then, like I said, for the local maximum and minimum, maximum must be smaller than 0 and the minimum bigger than 0. And then you also have inflection points. That's when your first order derivative is 0, as in the other cases. However, the second order derivative is also 0. And that's an example right here. So it basically means that the function in this case was going down, and then at some point it just, there was no slope. The slope was 0, but then it continues in the same direction. It's not changing direction. And that's what an inflection point is called. And then when you take a derivative, just always remember to not mix up these two. So if a is a constant, to not mix up that a, that for example, 2 to the power of x is not the same thing as x to the power of 2. So when you take the derivative, always check which is the case and apply the corresponding rule. Then to the partial derivative. So first notation, as you can see on top, it's a bit different than it was with only one variable. Now it's written this way. So down here, what you can see, you always have to specify which variable you were considering in your derivative. So if we're taking the derivative in respect to x or to y. In this case, it's in respect to x. Or you can also write it the way that you just put the little x right next to the f. But don't use these little dashes that you used to use for one variable, because that's not how you write it for multiple ones. And then below, you can see all the derivatives that you have to be able to calculate. So this is your regular function. Then these are your first derivatives that you need to know. So here it's in respect to x, here in respect to y. And then you can continue, you take this these values again, and you take the second order derivative where you end up with double the amount. Here twice in respect to x, here once x then y, and so forth. And remember that these two, as you can see, are the same. So if you calculate both ways and they end up being different things, then you had a mistake somewhere. So that's also a good possibility to check if your result is correct. Then, as I said, you always take it in respect to only one variable. What does that mean? So that means that the other variable you have, in this case, the other variable would be y, we can consider it as a constant. So you just think it's a number and you use it as if it was a number. So you only take the part, since a constant, we don't have to consider it for the derivative. We only take the part that's relevant for us, and you can take the derivative and basically put it back into, as you can see down here, to your y, which is a constant, and that's how you're supposed to do it. Then the total differential. So that's kind of for me, it was difficult concept to understand, but it's basically you try to approximate the change of, for example, your y function if something else of the input in the function changes. So the questions that are mostly, as the exercises mostly sound like, for example, what happens to y if x changes by delta x. So another example would be what happens to the production if the kilograms of, if the wood input changes by 5 kilograms. Okay, and then you have to calculate the change that will happen in the production. And on the right, you can see that it's just an approximation. It's not the exact value. As you can see, the exact value would be here, and this is our approximation. So the more the function is changing and the steeper the slope is, the less accurate it will be. It can also be done using two variables that are changing. So when two inputs are changing, as you can see here, and then you just add up the two things together. So you take the first derivative in respect to the variable that is changing and times it by the change in that variable, and you add it up with all the other changes that you have and end up with your final change. And you can do it with as many variables as you want to, but for us at the exam, I think it was mostly 3 that was in the exercises. Then sometimes the teacher asks to calculate the difference between the approximation and your estimation. So that means that you have to calculate what the actual change in y would have been compared to what your estimation was. So you basically take your function, you add up your change to the original value, and that's what you do in this part to get your new value, and you subtract the old value, and then you get the change in your y. And then sometimes the teacher asks you to compare them. So you often have to say, yeah, this is higher by a certain amount or by a percentage, depends on what the teacher asks you. Now, optimization, that's, I think, the hardest chapter for most of the people. That here, for example, we start with one variable. That means, as we've seen before, you look for critical points. That means that you set the first derivative equal to 0, check the concavity, as here in this example, for example, if it's smaller than 0, if it's a maximum or a minimum, and then you find the corresponding values at those points. That means that you put your x value back into the original function. Now with two variables. So it's again, the first order derivative must be 0 with respect to the both variables. And here you always have to check if your values actually are critical points in that sense. So you need to use the Hessian matrix, as you can see on the bottom right. That's basically also something to write down. It's written in the formula paper that you just have to remember to use it and not forget it, because not all the derivatives, not always when the first order derivative is equal to 0, it's not always a maximum or a minimum or a saddle point. Here it's called a saddle point, not point of inflection. The same principle, but inflection point is when you have just one variable. Saddle point is when you have two variables. And you also have a table for that in the paper that would look like this. So when your Hessian matrix is bigger than 0, it is a local minimum and maximum. And then you also have to take the second order derivative to check if it's bigger or smaller than 0 to know if it's a minimum or a maximum. And if it's smaller than 0, your Hessian matrix is a saddle point, and then you're done. You don't have to do the second derivative. And when it's equal to 0, then we don't know what it is, because it's a special point, because it's a three-dimensional function, and we cannot give any more information on that. Then unconstrained optimization. So I tried to like make kind of a recipe for you, because I know that that helps me a lot to know how I should proceed when I have such an exercise. So first of all, you should find all the critical points. So you set your first derivative equal to 0, and you solve for the unknowns. Then you put it back into your original function, as I've explained before. That's basically what you do with all kinds of finding maxima and minima. And then you have to find the determinant, which is the difference to when we just have one variable. When you have 3 variables, you have to find the determinant using the Hessian matrix and define, as you've seen before here, if it's a local maximum or minimum, saddle point, or if you have no information. And only then you go and check the concavity for the extremas. Because if for example, the Hessian matrix, the determinant is equal to 0, then it doesn't make sense to calculate it. You're just wasting your time, which would be a valuable time at the exam. Then we have the substitution method for the constraint optimization. So first, you should define your functions. So you always have 2 functions in this when you have a constraint. Firstly, your regular function, and secondly, your constraint, which here is g of x of y. Then you solve one of the 2 equations for one of the variables, for example, for y, and then you place it into the other function. That's all that you know. All this you know from the regular substitution method that you've seen at the beginning. It's just here in different contexts, but the principle is still the same. You just have more steps after it. So then you solve for it. You're only left with 1 variable, you solve for that. And then you have to apply the usual procedure that you know to get the critical points. And please never forget to use the Hessian matrix, because not every point will be a critical point. And then the Lagrange method, that's a bit longer and more complicated for me at least. So you start the same way. You define your function, regular function, and your constraint, and then you put it into your Lagrange function. So you basically just plug it in this way. And just remember that you plug in the regular function for the regular function, but for your constraint is usually equal to a number. So for example, k plus L must equal 50. So what you have to do, you have to put everything on one side so it's equal to 0. So if you have L plus K equals 50, it would be L plus K minus 50. And that's the function and the value that you have to plug in here. Never forget to do that step. And then you take the derivative in respect to each variable. So as you can see here, you will end up with 3 different first derivatives, which you all have to set equal to 0. The next step would be to solve the first 2 equations. So the ones that are, so these 2, which are in respect to x or in respect to y. You solve them for lambda. And then you set them equal to each other in order to solve for one of the variables. So that way you already got rid of one of your variables, you only have 2. Then you solve for one of those variables, like for example, it could look like this, that y is equal to 2x. And you plug it into your third derivative, which would be the last one, to find, and then you only have 1 variable left, and you can solve for it and plug it in and find all the other variables as you used to do it with other functions. And here, what's different is that you don't have to do the Hessian matrix. So don't waste your time doing it, because you won't get anywhere, because we have 3 variables now, and that's way too complicated. So we just assume at the exam that it's a maximum or a minimum or whatever we're talking about. And yeah. Then integration. So integration is basically the opposite of differentiation. Okay, so if you think how we would differentiate a function, we're just doing it backwards, as you can see in this example. So for differentiation, when you have x squared, you take the 2 down and do in the exponent 2 minus 1, and you get 2x to the exponent of 1. And when you do it backwards, you would get x squared times 1 over 2. Okay, and they cancel each other out because you have the 2 here. Yeah, and this is the way how you write it. And remember, because when you differentiate a function, when you have a constant at the end, like here a c, it just falls away because it doesn't have a variable with it. So if you integrate something, you have to always say that there is a number back there, but you just don't know what it is. For us, it's mostly not relevant. It's only relevant if you just have to integrate it and don't do anything else with it. But we mostly use it for other things, which I will show you right after. And here are your rules for the integrals. It's basically just, like I said, the derivatives backwards. And you have to remember some of the rules. And yeah. So what we use it for is when we calculate an area. So this way, the constant that you would get when you integrate the function cancel each other out. And that's why we don't have to consider it in this case, okay? And then you have your integration sign right here, and you have your lower limit and your upper limit. And you always take first the derivative, which you then write as a capital letter, so capital F here. And then you plug the upper limit in and you subtract from it the lower limit, and you get your area. And those A and B are called limits of integration. So to see it in a graph, this would be the part that you were calculating. So if in case that you have a graph, for example, if here a part of it is below the x-axis and a part is above, so part here, if you just do what we did up here, they will cancel each other out and will just be 0. So in order to avoid that, you define another value here. So if this was A and this was B, this would be C. And then you do it, oh, sorry, that's not what I meant. It's a different example. So if here it was A and here it was C, then the middle would be your B. And then you divide it up to get the first part and the second part. And it's always, like you can see here, those signs, those two lines here mean that you just take the absolute value. So you just take away the minus if there's one. Because an area cannot be negative if you're just talking about a specific area. Yeah, that's basically already it. I've tried to make it very quick, but it's probably a lot of information as well for you, since it's the entire semester in 45 minutes. So the PowerPoint will be given to you by in the chat. And if you have any questions, you can ask me now. And we probably are all studying for financial accounting. So in case you have any questions, like next week or anytime, you can send me an email or text me or whatever, and I'll try to answer it. Okay. Thank you, Maud. I'll check. Sorry, it's not opening for me. Okay. Solutions are okay. Okay. Let me just look at it real quick. Oh. Okay, I'll just try to solve it for myself first, so I don't tell you anything that's wrong.
Yeah, no worries. Thank you so much for helping.
No worries. Okay, so let me check what your results were. So 0, x1 0 and x2 2. Okay, so I honestly didn't get the right result right now. Yeah, I got different results, so I'm sorry, I can't help you, Maud. I don't know if Julia maybe knows. I have to look at it for a longer time, maybe.
Yeah, sure. It was really quick, but thank you so much for the tutoring.
No worries. Thank you. So, any other questions, maybe about the theory or anything?
Hey, Michaela. Sorry. First of all, yes, thank you very much for this. It's been quite helpful because I'm absolutely lost in math.
Okay.
Honestly, right now, because as you said, I've done a lot of other things, but definitely not math so far.
Yeah.
So maybe if that's okay with you, I'll come back to you with a question if one comes.
No worries. Like, I mean, I'll be also focusing on other exams the next days, but after the Excel exam, I'll also be studying a lot of math. So it will be helpful for me as well if you text me anything that you need help with. So yeah.
Great. Thank you. Thank you. This was great.
Okay. So yeah, Julia, I think that's it. So we're even done before the French section starting.
Yeah, I'm going there. Not stopping. Thank you, Michaela. And yes, guys, if you have any questions, just ask later when you'll be ready for that. And thank you for joining. Good luck for your exam tomorrow.